this is the rhodamine, and this is diluted, and it'll still stain your clothes.
Rhodamine?
Rhodamine, yeah.
Yeah. You're doing this aiming to do this every hour, if you have the battery, every half hour if the battery on the computer allows.
Yeah.
Yeah. So just that much?
Just that much.
Wow.
Yeah. And it'll completely
10
change the colour of the
millilitres
river.
in around time. Should I just do it now anyway?
Yeah.
Wow, that's amazing. That is amazing.
Right, so we've got a stage sensor here and a turbidity sensor. We set up the turbidity sensor for the master students, but you might also use that data.
And the okay, so sensors for stage, for height basically,
yeah.
and turbidity for the muddiness of the water.
Yeah, so the turbidity will measure the depth or the height of water above the sensor.
Yeah.
So as long as we know the distance from the bottom of it, then we can work out the height of water. And we're going to use that as a proxy for the volume of water flowing off the glacier.
So here we are now down here at the further downstream bend. What's going on here?
So this is the monitoring station for the rhodamine, so it'll pick up any trace of concentration.
Okay, you can't see the screen very well. It doesn't matter.
Oh right, okay. Well,
doesn't
anyway,
matter.
There's background concentration, and then as the rhodamine comes through, it spikes, and you can see it in this graph it's making. I don't know if you can see that. Maybe, maybe not.
Yeah,
it's a bit hard to see.
Okay, so it's sort of coming up the spike.
It comes up this spike, and so you can see it was like that, and then it goes like that. Maybe you can't see it. But, and this just tracks it in this thing. And we use a sensor. Which is
So is there a sensor? Is it what, a fluorimetry or something?
It's a fluorometer tracer. Basically, a professor at Lausanne made this himself. So
okay.
It's a mashup of many other sensors.
Okay.
But this is the sensor that picks up the rhodamine.
Cool. Explain to me the principle of dye tracing. What's it all about? Why put the dye in? Who wants to have a go at that one? So what's going on? Why do we need to do that?
We know the amount of grams of the dye that we put in, so once it's diluted and we measure the concentration downstream, we know how much it's been diluted by, so that we can work out the volume of water that it's been diluted in.
So it's a way of really accurately calibrating the stage height that we have.
Yeah.
So in other words, it's doing proper discharge to high quality data.
Yeah, and then we can link it to the height, so we have all throughout the night as well as through the times that we're not doing the dilution gauging.
And the big picture is you're looking at the seasonality, the diurnal pattern in glacial melt, and of course that's very, very topical.
Yeah.
Cool, fantastic. Awesome. So I spoke to you earlier when you showed me the work you were doing of the runoff from the glacier, and we were looking at the dye tracing from the flume. And now what we're doing here is we're doing some interesting analysis, because I understand you've taken samples throughout the discharge peak through the day, from the lower flow right through to the peak glacial discharge, which is about what, 4 or 5 in the afternoon, and then so on. You've got a sample here like this.
We've labelled them.
Oh, right, and you've got samples from different times like this. So, George, tell me a little bit more about what you're doing here.
Well, here at the moment we're just analysing phosphate levels in the water. So we have to filter it first because there's a bit of suspended sediment.
Yeah, yeah.
Then we add a reagent.
Yeah, yeah.
We use this.
Oh, cool.
We use a calibration sample here to get a 0 mark, and then you put the next sample in.
Yeah.
And just repeat that for all the samples, and we'll do the same for the pH.
Using a pH probe here.
Yeah.
Interestingly, because I'm interested in phosphate for my research, you've told me that you've got some kind of signal already. You've got a little bit of a colour detected in the sample, that's quite exciting. Yeah. I guess the challenge is what we're doing here is it's a great project. What from a phosphate scientist point of view, we're using this field equipment, and it's really quite robust. It works very well. What we need to do is just calibrate it and see that it's like a little fluorimeter or something that reads the sample in the field like that. You put it in there in a little vial, but we need to check exactly what we're getting. But I'm really interested in this because I'm asking the question more broadly in my research is what's happening when glaciers melt to the global phosphorus cycle. Just think about that because it raises some interesting questions. Excellent. Thanks very much, guys.